Hello. In this video we're going to look at some more curve sketching examples, and in particular we'll look at some more that involve some factoring on the first steps and have a bit more complicated sign diagrams for f prime and f double prime. So here we have fx, f prime, and f double prime given to us, but of course they're not factored. This needs to be factored as x minus 2, x plus 2. Over here we need to factor the top as x minus root 12. And x plus root 12, looking at that difference of squares. And then the other one is fully factored. So we're going to start with the domain. And the domain comes to us from looking at that denominator. So we get minus infinity to minus 2, union, minus 2 to 2, union 2 to infinity. We can find the y-intercept and the x-intercept by finding f of 0, which happens to be, well, just 0 over negative 4, so 0. So this is our x-intercept and our y-intercept. So the graph actually goes through the origin. Now we can go ahead and find the vertical and horizontal asymptotes. So let's look at the limit x approaches infinity of x cubed over x squared minus 4. We use the quotient theorem to get x approaching infinity of x cubed over x squared, which of course goes to just positive infinity, because x cubed over x squared reduces to x, and then we just plug in the infinity. If we go to negative infinity, we're going to get the same situation. X cubed over x squared minus 4, apply the quotient theorem, x approaches negative infinity of x cubed over x squared, and that will give us negative infinity. So this means we have no horizontal asymptote, because we're not getting a number, we're getting infinity. Now we can go ahead and find the vertical asymptote, which is going to happen at x equal to negative 2 and x equal to positive 2. Both of those are going to be vertical asymptotes based on the fact that they're coming from the denominator of f of x. So we would do limit x approaches negative 2 from the left of fx, limit x approaches negative 2 from the right, limit x approaches 2 from the left, and limit x approaches 2 from the right. Now all of these limits have to come from the sign diagram, so we'll just pause here and head back on over to the sign diagrams. So we've got f, f prime, and f double prime. So for f, we've got 0 at 0, and then we've got undefined at negative 2 and at 2. For the value bigger than 2, we say 10. We're going to get positive, negative, positive, negative. For f double prime, we've got it undefined, or 0 I should say, at 0. That's going to be even. We've got it undefined at 2 and negative 2. Those are also even. And then we've got more zeros at root 12 and negative root 12, which is a little bit more than 2. So we've got those as well. So we pick a number bigger than root 12, again, say 10. We're going to get positive. So positive, negative, 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 positive, which means the graph is increasing, decreasing, 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 increasing. So we've got ourselves right here a rel max, and right here a rel min. Let's go for that second derivative. Again, go to 0 at 0, undefined at 2 and negative 2. So we pick a value bigger, they say 10, positive, negative, positive, negative. So concave down, concave up, concave down, concave up. So each one of these is going to be an inflection point, except of course, even though it switches from concave down to concave up, this can't be an inflection point because the function is not defined, and similarly the function is not defined here. So even though we have concavity switches, this is going to be the only inflection point. Alright, so we'll take the information that we have here. We know as x approaches -2 from the left, we're going to get negative infinity. Then we go from the right, we're going to get positive infinity, negative infinity, and positive infinity. So we can fill in those values for our limits. So here we have negative infinity, positive infinity, negative infinity, and positive infinity. So this gives us a vertical asymptote at x equal to -2. And this gives us a vertical asymptote at x equal to +2. We also need to find all the coordinates, and we need to write the increasing and decreasing. So we'll write the increasing and decreasing next. So where is it increasing, decreasing, concave up and concave down? Again, we read this directly off of the sign diagrams. So it's increasing from negative infinity to negative root 12, union root 12 to infinity. It's decreasing on negative root 12 to -2, union -2 to 0, union 0 to 2, union 2 to root 12. Concave up on -2 to 0, union 2 to infinity. Concave down, negative infinity to -2, union 0 to 2. All right, let's find those important points. So we circled them in red there. We've got negative root 12 and root 12 and 0. We should plug all those in to see what we get in the actual function. Make a little space over here. We'll find f of root 12. So that gives us root 12 cubed over root 12 squared minus 4. So this will be 12 to the 3 halves, if you want, as an exponent. 12 squared, the square root, of 12 squared will just give us 12, and 12 minus 4 will be 8. So that will give us just 12 to the power of 3 over 2 over 8. Now we can't square root 12, unfortunately. If you cube it, you still can't square root it, so we're just going to leave that number as it is. We'll do f of negative root 12. So negative root 12 cubed over negative root 12 squared minus 4. The negative is going to square away in the bottom, giving you another 8. But in the top, it's going to stay negative, so we have negative 12 to the 3 over 2. We can also find f of 0, but we already did that at the beginning. So f of 0 is equal to 0. So these are, again, the 12 here is our rel min. This is our rel max. And this is our inflection point. So let's take all this information and do our best to draw the graph. So we've got x and fx. We're going to have asymptotes at 2 and -2. Let's do this as x equal to 2, vertical asymptote, and x equal to -2. We know there's going to be a point at the origin, which is also an inflection point. Now, if you actually look back at the derivative is actually 0 here. So not only is this going through the origin, and not only is this an inflection point, but it's also a horizontal tangent. So we're going to really want to make sure we draw properly at this point at the origin. Then we've got our points for the rel min and rel max. Now these are a little tricky. But we know that at x equal to root 12, which is a little bit to the right of 2, we've got ourselves a point at 12 to the 3 halves over 8, which is a positive number. So roughly, I don't know, something like that. And just label it. Root 12, comma, 12 to the 3 halves over 8. This is a rel min. Similarly over here, we've got a point at negative root 12, and negative 12 to the 3 over 2 over 8, and this is our rel max. All right, so those are all of our points. Let's go ahead and sketch the graph. So looking at the first derivative, we know that the graph should be below the x-axis here, then above the x-axis, below the x-axis, and above the x-axis. That comes from the sign diagram for just a function. Looking at the first derivative, we know it should increase, decrease, then decrease some more, and then decrease some more, and then decrease and then increase. And looking at the second derivative, we know it'll be concave down here, concave up, concave down, and then concave up. So using all that information, we should be able to draw the graph as something like this. So we've got a rel max right here, giving us something like this. Just going to move it over a bit. We've got ourselves the asymptote on this side. Again, if you're not sure whether it's coming from down here or up here, you look at the limit. As x approaches negative 2 from the right, we know that it's going to positive infinity. So we know we're coming up from this portion of the asymptote. So we come here, concave up, we swoop through our point, have a horizontal tangent line, and then we switch to being concave down. And then over here we've got a relative minimum. Again, we should say concave up the whole time. And there we go. So again, you can check through your information and make sure the graph matches the first sign diagram, the second and third sign diagrams. As long as it lines up with everything you have, you know you've graphed the correct function. And again, it's helpful. There's so much information here that if something's going wrong, there should be a bit of conflict between one of your sign diagrams, one of your points, maybe one of your limits, and so it should help you realize that, okay, I've made a bit of a mistake, and you can go back and work with it. Because if everything's working together, there's enough checks and balances that you know that you've graphed the question correctly. Now let's do a fun polynomial one here. We have fx, f prime, and f double prime given to us, and there's not a rational function, just a polynomial. So let's see what we get. Well, we're going to write the domain, which is going to be all real numbers. We can find the y-intercept and the x-intercepts. So the x-intercepts, they're going to be at negative 2 and 0, and then negative 1 and 0. The y-intercept, f of 0 equals 2 times 1, which will be 2. So we've got a y-intercept at 0 and 2. Because we have all real numbers for the domain, there's no need to check for vertical asymptotes. Horizontal asymptotes you could technically check for, but we know a polynomial is not going to have horizontal asymptotes. So we're going to skip those, and we're going to jump right into the sign diagrams. We've got f, f prime, and f double prime. So for f, we've got it being intercept at negative 2 and at negative 1. This one's even. Pick a number bigger than negative 1, say 10, positive, positive, negative. For the derivative, we've got negative 1 and now negative 5/3, that's going to be a little bit less than negative 2, so put it about here. Again, we're going to get positive, negative, positive. So increasing, decreasing, increasing. We get ourselves some definite relative maximums and minimum. Right here, we're going to get a rel max. And right here, we're going to get a rel min. Go ahead and do the second derivative. The only point we get is negative 4 over 3, which is, again, a little bit further back this way. negative 4 over 3, between negative 1 and negative 5 over 3. And then when we pick a positive number here, we get positive and then negative. So concave down, concave up, and we get ourselves an inflection point. Next up, we're going to find these values. So again, this is a good chance for you to practice some arithmetic. We need to calculate f of negative 5 over 3. So I encourage you to pause the video and see what you get for doing f of negative 5 over 3. Alright, so hopefully you gave it a try. You should be getting the following. Negative 5 over 3 plus 2 times negative 5 over 3 plus 1 squared, which will work out here to 1/3 times negative 2/3 squared, which will give us 4 over 27. All right, let's do f of negative 4/3. Again, I encourage you to pause the video and see what you get. All right, hopefully you got the following. Negative 4/3 plus 2, negative 4/3 plus 1 squared. That will give us 2/3 here, and negative 1/3 squared here, which works out to 2 over 27. All right, we should probably mention those intervals before we forget. So increasing, decreasing, concave up and concave down. Increasing on negative infinity to negative 5/3. Union, negative 1 to infinity. Decreasing on negative 5/3 to negative 1. Concave up on negative 4/3 to infinity, and concave down on negative infinity to negative 4/3. All right, let's sketch this polynomial. So we've got x and fx. We know our intercepts are at negative 2 and at negative 1. We know our y-intercept is over at 0 and 2, so we can put that up here as well. This is 0 and 2. Here we've got negative 2 and 0, negative 1 and 0. And if you were in pre-cal, again, this is all you'd know, so you'd know to kind of sketch roughly something like that maybe, or maybe something like that. You just go through the points, and maybe you might remember this one is going to bounce off of it because it's even, and you could roughly get the sketch of it. But it's nice to get actually the other points that we have now from calculus. And so we know that over at negative 5 over 3 and 4 over 27, we're going to have a rel max. So that's going to be somewhere about here-ish. So we're going to have negative 5 over 3 and 4 over 27. It's going to be our rel max. And honestly, that point at 0 and 2 might have to get moved up a little bit, just so it looks reasonable in terms of the scale. It doesn't have to be super accurate, but this is starting to look a little bit too low. So we're going to move that point up. So instead of being 0 and 2 here, I think we're going to move it up just a bit. So we're going to take that point. Maybe we'll place it later when we're done. And we also need to have the point of inflection, which is at 2 over 27 and negative 4 over 3. So maybe we'll put that right in there. Again, if you're not quite able to get the labeling in on the picture, you're more than welcome to just draw a little arrow and label it. This is going to be negative 4 over 3 and 2 over 27, and it's an inflection point. All right, so let's draw the graph. It's supposed to be below the x-axis to start, and it's going to come up increasing, concave down, so something like this. We're going to go through that point, make a rel max, turn around and stay nice and concave down here. Switch to concave up. And then afterwards we make a little rel min here and we continue on. Now we should make sure that intercept is a little bit higher. Maybe third time's the charm. Something like that looks pretty good. Add your arrows, and you can always put these points in after the fact. This is 0 and 2. Again, I know it's not perfectly to scale because this here is 4 over 27, which is much less than 1, and suddenly we're at 2. But the point, again, is not to have a perfectly exact graph. The point is to get the shape, to get the rough sketch of the curve, and to label the points. And that's what we've done here. Well, perfectly. Again, you could check it on Desmos, and the approximate shape of this graph here, where the peak, where the valley is, all of those are fantastic. So let's try a couple of questions here. Evaluate f of 2 over 3 given f of x as follows. All right, so if you practice your fraction skills, you should be getting 12 over 35. If you didn't get that, go ahead and try it again. Make sure you can work this out to get 12 over 35. Let's try another one. The limit as x approaches 1 from the left of the following. All right, so if you draw a sign diagram, you'll get -2 and -1, 1 and 3, positive, negative, positive, negative, positive. So as we go from 1 from the left, we're going to have positive infinity, so the answer is B. And one more, evaluate the following limit. Now this one's a little tricky. You might have to remember that x is equal to the square root of x squared plus or minus. And because x is approaching negative infinity, this quantity here is going to be less than 0. So we're going to take the negative. So we would get 5. Well, really, you should have probably 5x and make this a 25. So you're going to have 5x equals the square root of 25x squared. And that'll give you the square root of 16x squared over 25x squared with a negative in front and with a negative and another negative in front. So these x squareds cancel. These negatives cancel, giving you positive root 16 over 25, which gives you 4 over 5. Answer is C. So for homework, please try the curve sketching worksheet. There's questions 1 through 3. Each one has multiple parts. The first one is mostly focused on polynomials, just to get warmed up. The second part has some good rational functions, and the third one has a mix of some extra functions. So make sure you take a look at those. We'll have one more video on some curve sketching where I'll do a few more advanced examples, just to make sure that we look at all the different options that come up. As always, thanks for watching.